Good morning, good afternoon, or good evening, and welcome to the next episode of Numbers with Nando. We've learned how to fit a circle to 2 points if they're really nice, like if there was a point down here which was the same distance from both points. But I want to show you today how to fit a circle to any 2 points, whatsoever. Now, one way you can always fit a circle is to find the midpoint, because the midpoint is halfway between both points. So if you put the center in the middle, you can draw a circle that connects them. So we'll call M the midpoint. And the midpoint is the average of the x points. So 2 plus 4 is 6, divided by 2 is 3. The average of the y points is also 3. Okay, and the radius of the circle is the distance. So it's 1 away from here. The x point is 1 away, and the y point is 2 away. So it's like our Pythagoras. A squared plus b squared equals the c squared, which is the radius squared. So the radius squared is just going to be 1 squared plus the distance, the x distance plus the y distance. So x distance squared plus the y distance squared equals the diagonal distance squared. So that's going to be the radius. And fill in the rest. We had the center of the circle, so is that 3, so x minus 3 squared, and there we go. And we could, of course, simplify this to just being 5. Okay. So that's nice. Circle through any 2 points. But wait, there's more. What if we only wanted part of that curve? We didn't want the whole curve. What I would want to know is the line between these 2 points. And then I can only take the y values that are above that line. So I want to find the straight line between these 2 points. And we can actually do what we've always been doing. Switching it, moving across by A, C, and then finding the gradient. The same transformation works for a straight line. So we want to go through the point, or we can pick any point, let's just say 2, 1. So we want our line to be shifted across by 2, up by 1. And we want the gradient. So the gradient is rise over run. We go up by 3 every time we go across by 2. Oh, sorry, we go up by 4. Up by 4 every time we go across by 2. What do I go to? Is 2. Okay. So that is a line between those 2 points, but we only want the top half of this curve. So if we change this line here to an inequality, this purple shaded region is where y is greater than that line, which is exactly the curve we want. So we can actually put this here as the domain of our function, because we only want y values that are greater than this line here. I'll turn it back to equality. That are greater than that line there, which is exactly what we want. So that's pretty cool, I think. We now have a lovely arc between 2 points. And you thought this video was over, but we are just getting started. This black point is equidistant from both points. It's the same distance from both points. But if we think about it, anywhere on this perpendicular line is also the same distance from both points. If I travel out here, I'm the same distance from there as there. So I want the equation that goes through this center point and is perpendicular to this gradient here. Okay, so we want another line this is finding that perpendicular line. It goes through the midpoint, so through 3, 3. And the gradient is the negative inverse of that, so that it's perpendicular. So you just get you flip your fraction. So flip our fraction, so it's just half negative. Okay. So it goes through the midpoint, and the gradient is the negative inverse. Or negative reciprocal, which is the inverse. So now I have the equation of this line. So what I really want is this black point here to be anywhere on this line. So rather than just start at 3, 3, I want my point, we'll call it P for my center. Do I ever used a C? No, we use C for center. That's nice. I want to start it at, well, let's make a slider because we want this black dot to slide along. Okay, so C to equal K, comma, show you what I've done there. So I want the X value to be any number, X value to be K. And for any X value, this tells me the Y value. So the Y value is whatever the value is of K and transformed. So you can see that. Moving along. Okay, I'll make that black as well. So X can be any value. So I've just got a K. Okay, with a slight any value. And for any given X value, this tells me the Y value. Because that's what a function does. And so this here is the Y value. All right, so what can we do now? This is any possible center. So what I can do is make a, let's just grab this here. So instead of shifted 3, want to be shifted by, okay. And the Y value, instead of being shifted by 3, we want it to be shifted by, okay, so we've got our circle. But obviously our, so this should be okay. Okay. So the X value has been shifted by K, and the Y value shifted by the corresponding Y value. Okay, but as you can see, my radius is not big enough. So how big should the radius be? Well, it should be the distance from one of these points to the center. And so let's just figure that out. Let's just say the X distance. So the X distance, I'll call X1. X distance is going to be, we'll just do it from the top point B here. It's going to be 4 minus 4 minus K, because this is that X value coordinate K, and so the distance from here is 4 minus K. And we're going to square it, so it doesn't matter if it's K minus 4 or 4 minus K. We'll come out positive either way. And our Y value, the distance, is going to be 5 minus the Y coordinate of this point. We already know the Y coordinate of that point. There's this thing here. Okay, so that makes our radius, what do we want to call that? Well, the radius squared is going to be this value here squared plus this value squared. So I just want this value here squared using Pythagoras. A squared plus B squared equals c squared. So this is the radius. There's the center at k. The y value of the center, x distance squared plus y distance squared gives you the diagonal distance squared, which is the radius squared. Lovely jubbly. And look at that. It goes through that point. So all of these circles are going through those 2 points, which is pretty cool. Now, again, we only want that positive arc. So we can just copy our that domain, which is an inequality. That beast over here. And there we have it. Look at that. It's like a little bow and arrow. Which is pretty cool. Let's just appreciate that and watch it for a second. Okay, you'll notice it's going only a little bit this way and it's going heaps that way, which I don't really like. So I just want to fix that up for a second. So if I wanted to find as many circles on that side as on that side, I want to start from the center. I want my first x value, which is k, I want to start from 3. So that will be my first value, and I want to maybe go up by 10. So I start from my center. I want my x value to start at the center, by 10 each way. And then I'll have as many. That's a bit nicer. I've got as many circles on one side as the other. Okay. Now, I think that is definitely time to pause the video. That is a ridiculous looking equation, I will admit that. But you can pause the video and go back and understand each piece. So, hope you had fun there. See you next time.